Hey y'all, so today's video I'm going to show you how to find rate of change and y-intercept in a graph and in a table. So as you see here, we are given a linear equation. It is in slope-intercept form. That is the standard y equals mx plus b, where m represents slope and b represents the y-intercept. So a lot of scholars will see that this is the easiest form to graph from because all the information is given and there's no calculations needed to solve it. So with -3 being the y-intercept, I'm going to start from -3. That will be my first point. My slope is 3, but as we know, for slope, we need rise over run. So to turn a whole number into a fraction, you just put it over the number 1. So now we have a rise of +3 and a run of +1. So from -3, I'm going to go up 3, 1, 2, 3, and to the right 1. And I always suggest to do this 3 to 5 times so that you can have a more accurate line. 1, 2, 3, to the right 1, 1, 2, 3, to the right 1, 1, 2, 3, to the right 1. Now we can kind of see our line forming. At that point, take some type of straight edge and connect the dots. We know this will be a solid line because of that equal sign. It's okay if your line is a little bit off because we're not a computer. So now we can answer the questions. What is the rate of change? The rate of change is 3 because rate of change is the same as slope. The y-intercept is -3 because it represents the b and y equals mx plus b. B is the y-intercept. The y-intercept is -3. So now let's fill in our table. At -3, where is y? If we go to -3 on the x-axis, y seems to be at -10. But you can verify this by doing some math. And this is what I suggest you do because, like I said, we are not computers, so your line will be off. We have our equation, y equals 3x minus 3. We now see that x is equal to -3. So you do 3 times -3 minus 3. So I'm left with -9 minus 3. Y is equal to -12. So, like I said in my line, I thought y was at -10. That's why it's always best to cross-verify with math. So your y value is at -12. Now let's see where it's going to be at -2. Same equation, y equals 3x minus 3, but this time my input is going to be -2. 3 times -2 minus 3. -6 minus 3. Y is equal to -9. So in our table, where x is -2, y will be -9. Now soon you will see the pattern established. We said that our rate of change was 3. So for our y values, you will see that these will increase by +3 because that is our rate of change. But let's do a couple more examples. The next input is -1. So y equals 3 times -1 minus 3. So that's -3 minus 3. Y is equal to -6. -6. Now from this point, I'm just going to go ahead and add the 3 because now I can see that my pattern is established for sure. So -3 here. We can cross verify and see that at 0, -3, we do indeed have a point. So we know that our graph is right. 0, 3, and 6. We are done with that graph. Let's do one more example. This time our line is y equals -8x, but there is no b. So there is no b. This translates to b is equal to 0. So that means our first point will be at the origin. And then our slope is -8. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And to the right, 1. There's no room to keep going down, so I'm going to go up 8 and to the left 1. 1, 2, 3, 4, 5, 6, 7, 8, 1. And go ahead and draw my line to connect the dots. The rate of change is still the slope. It is still our m, -8, and our y-intercept is 0. To fill in the table, I'm going to do the same thing. I'll plug in -3 for x and solve for y. My linear equation is y equals -8x. My first input, is -3. So -8 times -3, y is equal to +24. My rate of change is -8, so all I have to do is subtract 8 from 24, and that gives me my next input. 24 minus 8 is 16. At -2, y will be 16. 16 minus 8 is 8. 8 minus 8 is 0. We can verify that with our first point. Where x is 0, that is the y-intercept. Our y-intercept is at 0, 0. Next, we have -8. As you can see, that is our point down here. 1, -8. At 2, it will be -16. And at 3, it will be -24. I hope this helps.